Hey guys, today we'll be solving the Jan 25, the latest paper of M1. So let's just get right into it, okay? I don't like giving intros. Alright, a particle of mass 2.5 kg moves on a smooth horizontal plane under the action of three horizontal forces F1, F2, and F3. And these are just given here, okay? All these forces, they have different directions as, as seen, like these are different vectors, right? So they're going to have different directions, like 6i plus 8j would be something like this, somewhat in this direction. And let's say the particle is right here. And minus 16i plus 12j, on the other hand, would be something like this, right? And minus 2i plus 8j would be something like this. Okay? Now, all these forces will create a resultant force. Okay, which is why it says that a particle of mass this moves on a smooth horizontal plane. This can only move if this has a resultant force, and we have to find the magnitude of the acceleration of the particle. So if it has a resultant force, of course it has an acceleration. How do we do that? Well, we can just use Newton's second law here, that is resultant force is equal to ma. Resultant force is just going to be the addition of all these vectors. When you have forces in vectors, you just add all them up straight up. Okay, so yeah, let's do that then. 6i plus 8j plus, minus 16i plus 2j. We just add them all up. No subtraction or anything, just add them up. So minus 2i plus 8j, that will give us mass times acceleration is 2.5 times a. Now, if we make a the subject here, let me just put this whole thing into the calculator. Okay, first of all, 6 minus 16 minus 2, I'm just gonna find the I component, which is okay. Also, let's just bring the 2.5 on this side as well, and inside the vector is going to be minus 12i, and for j we're gonna have 8 plus 8 plus 2, that is 18j. All right, now minus 12 divided by 2.5 is going to give us minus 4.8, minus 4.8i plus 18 divided by 2.5 gives us 7.2j. This is our acceleration. Now hold on. This is not the end, because they're asking for the magnitude, right? We have to find out the magnitude. This is just acceleration in the vector form. What is the magnitude? Well, you remember how we drew the forces here in different directions? Well, these are denoted using vector forms, and each of these forces have a resultant. They are acting in a certain direction, and toward that direction, in that direction, is where the force is actually being exerted on. So for 6 and 8, the resultant force would be square root of 6 squared plus 8 squared. Why? Well, if you just construct this triangle, well, this was the 6 and 8 force. You have 6 here, 8 here. I'm concerned about the length of this, the length being the magnitude in this case. So 6 and 8, this is a right angle triangle, and you just do Pythagoras and find this out, right? That is how we get root over 6 squared plus 8 squared. That is the resultant force. Similarly for acceleration as well, if you have the vector form of acceleration and you want to find out the magnitude, you just do the same thing. So we denote it like this, two lines like that, and there's going to be root over 4.8 squared plus 7.2 squared. Square root of 4.8 squared plus 7.2 squared, that is going to be 12 root 13 over 5. And I'm pretty sure you can keep your answer as it is, like just like that. Or if you just want to be safe, just give your answer to 3 significant figures, which is 8.65 meters per second squared. There we go. Okay. A fourth force F4, where Pi plus Pj newtons, where P is a constant, is added. Okay, another force is now being added, and the resultant of the four forces act in the direction of the vector this. Now, here's the thing. It doesn't even matter that there's a mistake in the question, because we understand what they're trying to say. Like in the first page here, it says, the question currently reads, the resultant of the four forces acts in the direction of the vector 7i plus 2j, but it should read, the resultant of the four forces acts in a direction that is parallel to the vector. I mean, that is what we understood from that sentence, but it really doesn't matter. We just know that the final resultant force, okay, of F1, F2, F3, F4, the entire resultant force will act in the direction of the vector. Now, this will be useful in finding out P. I was gonna say P and Q, but there's no Q. Both components are P. Okay. First of all, our first task is to find out the resultant, right? So let's do that. Okay, this was part A, and wait a sec. This is A, and this is B. All right. F1 plus F2. Okay, let's just do like resultant force. Okay, you know what? Let's just do this. Resultant force should be equal to what is it? Okay, we've already added the 3 ones, which is this. So why don't we just use that here? Minus 12i plus 18j plus pi plus pj. And you know what I always like to do? I always like to keep the I components together and the j components together. So what I'm going to do is write this down just like this. P minus 12i plus 18 plus pj. All right. This is going to be in newtons, of course. It doesn't really matter. Okay, there goes the resultant force. And this resultant force acts in a direction that is parallel to the vector 7i plus 2j. Okay, now, when we say that a vector is parallel to another vector, that just means they're, okay, we can't exactly say that they're pointing in the same direction because, well, you could have a force pointing this way and a vector pointing this way. They're still parallel, but in opposite directions. But you know what I mean? They're just along the same line, essentially. That's what I'm trying to say here. So what we can do is we can take the ratios. I think we've already learned this. But another way to think about this is, let's say, let's just draw this right here. Just a small graph, okay? We have P minus 12i and then 18 plus pj. Let's say we have something like, okay, first of all, before drawing this, let's draw the vector 7i plus 2j first. What is it gonna look like? Well, this is 7, and let's say this is 2. This is all just assumption, okay? I'm just doing it for the sake of it, just to show you a visualization, essentially. Okay, so we have this, and now these two vectors are parallel, meaning this vector right here has to point, doesn't necessarily has to point in the same direction. It could even be here, but now we're just assuming that this is in this direction, in the same direction. But the main thing is that it has to be parallel. And if you're wondering why I drew this here specifically, well, it doesn't really matter. You could draw it here, whatever. Okay. Now, what I'm going to try to show you is how this thing actually comes to be. You know what we do? We just take p minus 12 divided by 7 is equal to 18 plus p divided by 2, and then we just solve for p. But I just want to show you how this equation is being derived. So here, if two lines are parallel, then the angle that they create with the horizontal axis is theta. And the theta is the same thing for both the lines because they're parallel. Now, if we know that both of them have the same theta, then we can actually find expressions using that theta and somehow equate them to finally get an equation like this. Let's see how we can do that. Well, for this triangle right here, we have this length 2 and this is 7. We have the opposite and the adjacent sides. So we're going to take tan theta is equal to 2 over 7. And for this one, for this one, this was the vector, the resultant force. So here the horizontal component is p minus 12 and the vertical component is 18 plus p. So now, what do we do? What do we do? Yeah, okay, so now we're going to take tan theta for this triangle as well, okay? Let's do that. Tan theta is equal to opposite over adjacent. Now, you notice this is also tan theta and this is tan theta as well. So we can equate these two terms. So 2 over 7 must be equal to 18 plus p divided by p minus 2, 12. And now if you actually rearrange this, you're actually just going to get this equation back, okay? So let me just show you how we can do that. We can bring the 2 to the other side here in the denominator and bring the p minus 12 in the numerator, and that just turns into this. So you see how we can actually derive that. But there's a caveat. If you have, let's say, a vector, let's say this vector was parallel to minus 3i plus 2j, okay? Let's say this was parallel to minus 3i plus 2j. What would we do then? Similarly, let's try to draw a graph. Whoops, that's not a graph. That was an ellipse, whatever. Okay, minus 3i plus 2j, it would look something like this, right? This is the minus 3i plus 2j. This is minus 3, and this is 2. Now, that means that this resultant force is also parallel, so this must also be in this direction, basically. Now, p minus 12 is going to be this, and 18 plus p is going to be the magnitude of this. You'd still take theta here and work out some stuff, right? So you have tan theta. Tan theta is going to be for this. Okay, let's do it for this triangle first, the larger one. That's going to be 18 plus p divided by p minus 12. Okay, this is what we have, and now we want to find out an expression for tan theta for the smaller triangle. For the smaller triangle, what we would do essentially is just take 2 divided by 3. You know how we solve trigonometric equations, where we just worry about the basic acute angle? But here, this is actually minus 3, right? So you would actually have to take minus 2 over 3, and we know that tan theta in this quadrant is actually negative, isn't it? Yes, it is. Right. So then you have to actually include this minus 2 by 3. I know it's a little bit counterintuitive. I haven't found a way to actually explain this, even to myself, but that is how it should be actually. So you wouldn't just do like 2 over 3, okay, and then just equate 2 over 3 to this. You wouldn't do that. What you would have to do then is just take minus 2 over 3 and then equate to 18 plus p divided by p minus 12. I hope that makes sense. Let's just go back to our question right here, and the value for p, if we just calculate real quick, first of all, let's just bring this here. 2p minus 24, that's going to be equal to 7 times 18. 7 times 18 is going to be 126. 126 plus 7p, and we have 5p, that is equal to minus 126 minus 24, that is, wait a sec, oh god, minus 150, and p is just going to be a minus 30. Okay, that is our answer. Now, keep in mind, I don't have the mark scheme with me right now. This paper is in its early stages. We're probably going to be getting the mark scheme right after March 6th, I think. Hopefully. Okay.